In this question, you have to simplify your complex number I into minus 3 by 5i in the form of a plus ib. So let's simplify. Minus 3 by 5 will be as it is, and I into I will give us I square, and we know that the value of I square is minus 1. So minus minus becomes plus, and your complex number will be 3 by 5, and we can write down plus 0i. So we get a plus bi form, where the real part of the z is 3 by 5 and imaginary part of the z is 0. Whenever your imaginary part is 0, then it is called purely real part, purely real number. Ta-da! Let's simplify our complex number I raised to 9 plus I raised to 19 in the form of a plus ib, and for that we have to divide the power of I by 4. We know that 4 2s are 8, so you will get 1 as a remainder. So we can express your I raised to 9 as I raised to 4 2s are 8 plus 1, which is your remainder. Similarly, to simplify 19, let's divide your 19 by 4, and we know that 4 4s are 16. So you will get 3 as a remainder. So your second term will be I raised to 4 4s are 16 plus 3 as your remainder. Now let's further simplify. We have I raised to 4 the whole square into I raised to 1. Similarly, in second term, we have I raised to 4 whole raised to 4 into I raised to 3. Now we know that I raised to 4 is 1. So here we have 1 square, and your I raised to 1 will be I, plus again I raised to 4 is 1. So we don't have to worry about it. And your I cube will be minus I. So I ones are I, and minus I ones are minus I. So I minus I will be 0 plus 0i is your complex number in the form of a plus bi, where real part of the z is 0 and imaginary part of the z is also 0. Ta-da! We have to simplify our complex number z is equal to I raised to minus 39 in the form of a plus ib. So let's simplify. Due to this negative sign, we have to write down 1 upon I raised to 39. Now, to reduce the power of this 39, we have to divide your 39 by 4, and we know that 9 4s are 36. So we will get 3 as a remaining term. So I raised to 39 can be rewritten as I raised to 4 into 9 will give us 36 plus your remainder, which is 3. So we can split our denominator as I raised to 4 whole raised to 9 into I raised to 3. We know that your I raised to 4 is nothing but 1. So you get 1 raised to 9, and your I raised to 3 is minus I. So we will get minus 1 upon I. Now we know that your 1 upon I is also minus I. So here minus minus becomes plus, and we will get z is equal to 0 plus 1i, which is in the form of a plus bi, where the real part of the z is 0 and imaginary part of z is 1. Whenever your real part is 0, it is called purely imaginary number. Ta-da! In this question, you have to simplify your complex number minus 2 minus 1 by 3i whole cube in the form of a plus ib. Actually, your complex number is in the form of a plus b the whole cube, which can be expanded as a cube plus 3a square b plus 3ab square plus b cube. So, your complex number will become minus 2 cube plus 3 times minus 2 the whole square into minus 1 by 3i plus 3 times minus 2 into minus 1 by 3i the whole square plus minus 1 by 3i the whole cube. Now let's simplify. Minus 2 the cube will give us minus 8, and here your 3 will cancel out and will get minus 4i. Your third term will be minus 2 by 3i square, and finally your last term will be minus 1 by 27i cube. Now we have to place the values of I square and r cube. So minus 8 and minus 4i will be as it is. Your I square is nothing but minus 1. So here we'll get plus 2 by 3, and your I cube is minus I. So here we'll get plus 1 by 27i. Now let's collect the real terms, which are minus 8 and 2 by 3. And from the imaginary terms, we have to take I common. So we will get minus 4 plus 1 by 27. So minus 8 plus 2 by 3 will give us minus 22 by 3, and minus 4 plus 1 by 27 will give us minus 107 by 27. So we get our complex number in the form of a plus ib, where the real part of the z is minus 22 by 3 and imaginary part of the z is minus 107 by 27. Ta-da! Here we have to express the complex number in the form of a plus ib, and for that we have to simplify the terms. Let's multiply 3 within the bracket. 3 sevens are 21 plus 3 sevens are 21i. Similarly, in second term, we will get I into 7 will give us 7i plus I into 7i will give us 7i square, and we know that the value of I square is minus 1. Now we have to collect real parts. 21 minus 7 will give us 14 plus 21i plus 7i will give us 28i. So we get our complex number in the form of a plus bi, where the real part of the z is 14 and imaginary part of the z is 28. Ta-da! Here we have to simplify our complex number in the form of a plus ib. So first of all, let's open the bracket. In first bracket we have 1 minus I, and in second bracket we have to change this sign due to this negative sign. So we'll get plus 1 and minus 6i. Now for simplification we have to collect all the real terms. So 1 plus 1 will become 2, and the imaginary terms are minus I and minus 6i will give us minus 7i. So we get our complex number z in the form of a plus bi, where real part of the z is 2 and imaginary part of the z is minus 7. Ta-da! Here we have to simplify the complex number in the standard form. So let's open the bracket. Your first two terms will be remain as it is. Now in second bracket we have to change this sign due to this negative sign. So you'll get minus 4 and minus 5 by 2i. Now let's collect the real terms, which are 1 by 5 and minus 4, which will give us minus 19 by 5. And by taking summation of imaginary terms, which are 2 by 5 and minus 5 by 2, we will get minus 21 by 10 I. So, we get A plus BI form, where real part of the z is minus 19 by 5 and imaginary part of the z is minus 21 by 10. Ta-da! Now let's try to simplify the complex number into the standard form. Open all the brackets. So 1 by 3 plus 7 by 3i plus 4 plus 1 by 3i will be as it is, and due to this negative sign we have to change the signs. So we'll get plus 4 by 3 minus I. Now let's collect all the real numbers to get real part. So 1 by 3 plus 4 plus 4 by 3 are the real parts, and from the rest of the terms which are imaginary part, we can take I common. So we will get 7 by 3 plus 1 by 3 minus 1. So 1 by 3 plus 4 by 3 will give us 17 by 3, and 7 by 3 plus 1 by 3 minus 1 will give us 5 by 3. So we get our complex number into the standard form of A plus IB, where the real part of the z is 17 by 3 and imaginary part of the z is coefficient of I, 5 by 3. Ta-da! Here we have to simplify our complex number into the standard form. Your complex number z is 1 minus I raised to 4. So let's simplify. Let's take whole square of 1 minus I whole square, and we know that A minus B the whole square can be simplified as A square minus 2AB plus B square. So we can open the inner bracket by 1 square minus 2 times 1 into I plus I square. In further simplification, we can say 1 square is 1, the second term will be minus 2i, and we know the value of I square, which is minus 1, the whole square. So your 1 will cancel out, we will get minus 2i the whole square, which is nothing but 4i square. Again substitute the value of I square, which is minus 1, we will get minus 4 plus 0i, can be considered as your standard form of complex number A plus BI, where real part of the z is minus 4 and imaginary part of the z is 0. So whenever your imaginary part is 0, the complex number is called purely real number. Ta-da! In this question, we have to simplify our complex number 1 by 3 plus 3i whole cube into the standard form of A plus BI. So your complex number is actually in the form of A plus B the whole cube, which can be expanded as A cube plus 3 times A square B plus 3 times AB square plus B cube, where your A is 1 by 3 and B is 3i. So your complex number will be 1 by 3 the whole cube plus 3 times 1 by 3 the whole square into 3i plus 3 times 1 by 3 into 3i the whole square plus 3i the whole cube. In further simplification, 1 by 3 the whole cube is nothing but 1 by 27. Then, so second term will be I In third term, 3 will cancel out, we will get 9i square, and in last term, we will get 27i cube. So, we can say 1 by 27 and I will be as it is. Now, we know that your I square is nothing but minus 1. So, third term will become minus 9. Similarly, your I cube is minus I. So, last term will become minus 27i. Now, you just have to collect real part, which is 1 by 27 minus 9, and from the rest of the terms, which are imaginary part, we have to take I common. So, we will get 1 minus 27. So, 1 by 27 minus 9 will give us minus 242 by 27, and 1 minus 27 will give us minus 26i. So, we get z is equal to a plus bi form, where real part of the z is minus 242 by 27 and imaginary part of the z is minus 26. Tada! In this question, you to find multiplicative inverse of complex number root 5 plus 3i. So, let's try to get reciprocal of it, which is 1 upon root 5 plus 3i. By multiply and divide by conjugate of it, which is root 5 minus 3i. Now, in numerator, 1 into root 5 minus 3i, root 5 minus 3i, upon, in denominator, we have a plus into a minus b form, which will become a square minus b square. So, in this case, we will get root 5 square minus 3i whole square. So, your numerator will be as it is, and in denominator, root 5 square will become 5, and 3 square will be 9, and I square will be minus 1. So, this minus minus become plus. We will get root 5 minus 3i upon 5 plus 9, which will become 14. To get standard form, let's give individual denominator. So, we get our multiplicative inverse in the form of a plus bi, where the real part of your complex number is root 5 by 14 and imaginary part of your complex number is minus 3 by 14. Tada! Let's find out multiplicative inverse of complex number 4 minus 3i. So, let's get inverse of complex number. So, get 1 upon 4 minus 3i, and for that, you have to multiply and divide by conjugate of it, which is 4 plus 3i. So, in numerator, 1 into 4 minus 3i will be 4 plus 3i, and in denominator, we have a minus b into a plus b, or we can say we will get a square minus b square. So, our denominator will become 4 square minus 3i the whole square. So, your numerator will be as it is, and in denominator, we will get 4 square, or we can say 16 minus 3 square will be 9, and I square will be minus 1. So, minus minus become plus. So, we will get 4 plus 3i upon 16 plus 9, or we can say 25. For simplification, let's give individual denominator. So, we get our complex number in the standard form of a plus bi, which will give us real part of your complex number is equal to 4 by 25, and imaginary part of your complex number is 3 by 25. Tada! Let's try to get multiplicative inverse of complex number z is equal to I. So, to get reciprocal of z, you value of 1 upon I is simply minus I, or we can say we have 0 minus 1I. So we get our reciprocative inverse in the form of A plus BI, which will give us real part of complex number as 0 and imaginary part of complex number is minus 1. Ta-da! Here we have to simplify our complex number in the form of A plus I. So let's talk about numerator. In numerator we have A plus B into A minus B form, which will become A square minus B square. So we will get 3 square minus root 5IB whole square. And in denominator, root 3 will cancel out and we will get 2 times root 2y. In further simplification, your 3 square will become 9 minus root 5 square will become 5 and I square is simply minus 1. In denominator, we have 2 root 2 and 1 upon I. So minus minus become plus, we'll get 9 plus 5 will become 14 upon 2 root 2. Your 1 upon I is simply minus I. So we will get Z is equal to 2 sevens are 14, or we can say minus 7 by root 2I. Here the real part is 0. So we get A plus BI form, where the real part of the Z is 0 and imaginary part of the Z is minus 7 by root 2. Ta-da!